So today in this session we will be dealing with the first chapter, set theory. Before we proceed with the mathematical concepts involving set theory, we shall learn what is a set. When I say the term set, what is the first thing that comes to your mind? So I would say a set is nothing but a collection of objects of a particular kind. For example, if I have to give you vowels in English alphabets can be a set, and then novels written by Chetan Bhagat, that can be a set, and then Rivers of India, this can be a set. If you observe, all the above mentioned examples are specific and well defined. Now let me reframe my definition of sets. A set is a collection of well defined objects. What do I mean by well defined? If I say, give me a collection of 5 most renowned musicians, is it well defined? No, because 5 most renowned musicians according to you is different and according to me is different. So it is mostly opinion based and varies from person to person. It is not specific and it is not well defined. Although it is a collection, it cannot be a set. This is what I mean. These are some of the important sets used in mathematics. Like we all know, the natural numbers are nothing but the counting numbers. It starts from 1, 2, 3, 4 and so on. Z is the set of all integers, meaning we have all positive numbers, negative numbers and 0. Q is the set of all rational numbers, numbers which can be expressed in the form of P by Q, where Q not equal to 0. And then R, set of real numbers, like all the above sets come under real numbers. And then Z plus is a set of all positive integers. In the set of integers, if I consider only positive numbers, that will be my Z plus. W is a set of all whole numbers, meaning 0 along with natural numbers will constitute the whole numbers. The numbers are this way, 0, 1, 2, 3 and so on until infinity. Objects, elements and members are synonymous terms. Everything means the same. And sets are usually denoted by capital letters and the elements are represented by small letters. And if I have to say the element A belongs to a set A, then I use my symbol called epsilon, and you can see the highlighted region there in the fifth line. It says A belongs to A, that is A epsilon A. That is how I write belongs to, and if any element does not belong to set A, then I write epsilon and a bar on it, meaning B not belonging to B. There are 2 types of representations of set. One is roster form, the other one is rule form or set builder form. In roster form, the elements of a set are written in a pair of braces. That is, we will be listing down each and every element of the set. If I ask you, what are the numbers, even numbers that come between 1 and 10? We obviously will say 2, 4, 6, 8 and 10, isn't it? We are listing down the elements here. And then if you observe the second example, it says integers between -1 and 5. Here you have to include -1 because it is less than or equal to, and on the other side you have x less than 5, meaning strictly less than 5. You shouldn't include 5. So what are the integers that come between these 2 numbers? They are -1, 0, 1, 2, 3 and 4. If you imagine your number line, real number line, then this is easy. In set builder form, we will be describing the set by a particular rule. Every element that belongs to this set has to satisfy that particular rule. For example, I have x such that x is a natural number. So any number which is natural will belong to set n. And p is nothing but x is a prime number less than 100. All the prime numbers which are less than 100 belong to the set p. And x is a letter in the English alphabet. Any element satisfying this rule, it should be a letter in the English alphabet. Any element satisfying this rule can be written under set A. So this slide will be helpful in understanding the difference between the set builder form and the roster form. And the first one under this, the set of all vowels in English alphabet. If I have to write it in rule method, I will mention the rule. What is the rule here? X such that X is a vowel in the English alphabet. That is the rule. And if I have to list down the elements, I will write A, E, I, O, U as my elements. In the second example, we have the set of all odd positive integers less than or equal to 15. So it is less than or equal to 15 and it is odd number. So all the numbers ranging between 0 and 15, including 15, can be written under this set. If I have to list down all my elements, meaning if I have to write it in my roster form, I'll be writing 1, 3, 5, 7, 9, 11, 13 and 15. Note, all the elements here are odd and they are less than or equal to 15. The third example says the set of all positive cube numbers less than 100. If I have to write it in rule method, it will be x such that x is a cube number and the rule will be 0 less than x less than 100. Meaning the numbers ranging between 0 and 100 and it should be a cube number. All the elements satisfying these two properties can be written under this set. Which are the numbers which satisfy these properties? 1 cube is what? 1. 2 cube is what? 8. 3 cube is 27 and 4 cube is 64. All these numbers are cube numbers and they appear between 0 and 100. In the next concept, we have types of set. Under that, the first one we have empty set, the second one we have finite set, third one we have infinite set, and the fourth one is equal set. So what do I mean by empty set? A set which does not contain any element is called an empty set or a null set or a void set. You can call them by any of these names. For example, I have an example which says A is equal to X such that X is an even prime number greater than 2. Can we find any number or any element satisfying this particular property? No, we cannot find an even prime number greater than 2. And hence A is a null set. And B, we have X such that X lies between 1 and 2 and X is a natural number. We all know natural numbers are counting numbers which start from 1, 2, 3 and so on up to infinity. We cannot find a natural number between 1 and 2. We can find only decimal numbers. And hence the set B is null. Finite and infinite sets. As the name suggests, this is self-explanatory. Finite meaning which consists of definite number of elements or which is empty. Such sets can be called as finite, else it is called infinite. For example, I have M as a set of months in a year. So this has a definite number and hence this is finite. The second one, S is a set of solution of the equation x square minus 16 is equal to 0. And the solution for this equation is also a definite number and hence it is finite. If we look at the last two examples, it says set of natural numbers. There are infinitely many natural numbers, hence this set is infinite. Set of odd numbers 1, 3, 5 and so on. There are infinitely many odd numbers and hence this set is also infinite. The next one we have equal sets. If I have to say two sets A and B has to be equal, they have to have exactly the same elements. As in, if we consider the following example, I have A is equal to 1, 2, 3, 4 as my elements. I have B is equal to 3, 1, 4 and 2 as my elements. If we observe in set A, 1 is there in A and 1 is there in B also. 2 is there in A, 2 is there in B also. 3 is there in A, 3 is there in B and similarly 4. Irrespective of in which order they are arranged in B, if the elements are exactly the same in both the sets, such sets can be called as equal sets. There are other types of set. We have already discussed the first four. The fifth one says unequal sets. If there are two sets x and y with at least one uncommon element, even if one element is not there in the other, then such sets can be called as unequal sets. Equivalent sets. Suppose I have my set x with the elements defined by elements 1, 2 and 3 and another set y as A, B and C. I can call these two sets as equivalent sets because they have the same number of elements. X also has the same number of elements, which is 3. Y also has the same number of elements, which is 3. And hence these two sets can be called as equivalent set. The next one is singleton set. What is a singleton set? The set which contains just one element is called a singleton set. For example, if I have to say X is a set such that which contains even prime number. Which is the even prime number that we know? 2. And hence it is a singleton set. And universal set. It is a set of all elements in a particular context. For example, if I have to say real numbers. And we have number of subsets of real numbers. Like we have natural numbers, we have whole numbers, we have integers, and so on. In this context, I can call real number to be my universal set. So in this session, we will be learning subsets and intervals. What's the meaning of a subset? For example, if I have a set B and another set A defined by elements 2, 3, I can say that A is the subset of B. I can say A is the subset of B. Under what condition? If I consider any element in A, if it is contained in B, then I can say A is a subset of A. Every element of A needs to be contained in B. In such a case, I can say A is a subset of B. In fact, to be very specific, this can be called as a proper subset of A. Why? Because A is not equal to B. A is called the proper subset of B, and then B is called the proper superset of A. That is the meaning. Can I say B is a subset of A? Yes. Why? Any element I consider in B is present in A. So I can say B is a subset of A. Can I say A is a subset of B? Yes. Why? Any element I consider in A is contained in B. So I can say A is a subset of B. If any two sets satisfy these two conditions, then they can be called as equal sets. A is equal to B. From this definition, it is very evident that any set is a subset of itself. What do we conclude? Any set is a subset of itself. And null set, that is 5, null set is represented by this symbol 5, is a subset of every set. It's a subset of every set. And the next concept that we will be dealing is intervals. What are intervals? Let's consider any two real numbers in such a way that A is less than B. The set of all points between A and B can be represented in the form of an interval. We have two kinds of interval. One is open interval and the other one is closed interval. What is an open interval? Suppose I have two numbers, say 3, comma 8. These are real numbers, and 3 is less than 8. Yes, it satisfies this condition. Now, I should represent this in the form of an interval. Open interval 3, comma 8 contains all those points between 3 and 8, but does not include themselves, does not include the endpoints themselves, which can be written in roster form as this way. So this set contains all the elements between 3 and 8, but does not include the endpoints. Does not include the endpoints. That is what it means. It can have numbers from 3.00001 up to 7.9999. It cannot reach 8 there. It cannot reach 3 on the other side. This is what open interval means. Closed interval 3, comma 8 is a set of all points between 3 and 8, including the endpoints. Meaning, it will be written as this way. So this set, closed interval 3, comma 8, contains all the elements between 3 and 8, including the endpoints. Please note here it is strictly less than in open interval. In closed interval, it is less than or equal. Well, on the other side, we also have so this is open on one side and closed on the other side. How do we represent this set? This interval can be written as a less than x less than or equal to b. So this is how this can be written as where this is a strictly less than x less than or equal to b because it is closed on the other side and hence it is less than or equal to. In the other one we have x such that a is less than or equal to because we have closed interval here x less than or equal less than b. We have open interval here and hence it is strictly less than. And length of any interval a comma b can be given by b minus a. This is called as the length of interval any. In the next concept, we will be dealing with power set. What is a power set? Let's learn it with an example. Suppose I have a set A with elements A, comma B. Let's list down the subset of A. It can be A alone. And like I told you, phi nut set is a subset of every set and every set is a subset of itself. So these two are mandatory, right? These are the subsets of set A. If I put all these under a set, this is called a power set and it is represented by P of A. Meaning, a power set is a set of all subsets of a set. So, power set is nothing but a collection of all the subset of set, isn't it? It is a collection of all subsets of a set A. So this is what power set means. So what is the cardinality of A? Cardinality of any set is the number of elements that the set contains. So what is cardinality of A? We have 4 elements. And cardinality of the power set is what? We have 4 elements. So in general, we can write cardinality of any set if it is n. Then cardinality of its power set will be 2 bar n.